Alright, so here's the second half, or part 2, of activity 6.3.4, the mechanics of the elimination method. So sometimes you can eliminate a variable by multiplying one of the equations by the same number on both sides and then adding it to the other equation. But which equation would be multiplied and by what number? You also have to ask yourself which variable would be eliminated when you do that. I'm going to insert a 1 in front of any variable that does not have a coefficient because there's an invisible 1. I'm looking at the signs, the positive 1y and the negative 2y, since they're opposite signs. I just need to make sure the numbers are opposite. So I'm going to multiply that top equation by 2. Well, spoke too soon. 2 times 2, remember, is 4x. I was thinking 2 times 1 is 2. Okay, so 2 times 1y makes 2y. So my first equation will be rewritten as 4x plus 2y equals 4. So notice 3x and 4x will combine, but the negative 2y and positive 2y will cancel each other out. So the y will be eliminated. Becomes 7x equals negative 7. Divide both sides by 7, I get x equals negative 1. For number 11, again, I'm just going to insert a 1 in front of the x so that I know that it's a negative 1x. That'll be important later when I want to go back and solve. So just remember 3 times negative 1 will get me the negative 3 that I need to have negative 3x. When I distribute the 3 to 2y, I get 6y. 3x and negative 3x cancel out because the x is eliminated. 5y and 6y become 11y. Negative 1 and negative 21 become negative 22. Divide both sides by 11. I get negative 2 for y. I will go back and solve for x in the next step. As you can see, the top I'm going to decide to multiply by negative 2 just because there are no negatives in this particular combination. So I'm just going to multiply because the coefficient of x in the first equation is 1. I'm going to multiply everything by negative 2. 2x and negative 2x cancel out. 4y and negative 6y make negative 2y. 7 and negative 10 make negative 3. And guess what? I've got a fraction. But I can deal with it because negative 3 divided by negative 2 is a positive 3/2 or 1.5. And that's a pretty easy one to deal with. At least it's a terminating decimal and not one of those repeating decimals where we tend to lose ourselves when we're approximating. Okay? I'm going to replace x into the top equation, and instead of 2x, I'm going to put 2 times negative 1 plus y equals 2. 2 times negative 1 is negative 2. Add 2 to both sides, so y will equal 4. When I put it together, my point of intersection, x goes before y, so negative 1, positive 4. In the second set, looks like pink, like a pink berry, a nice magenta, fuchsia. No fuchsia? Yeah, probably more fuchsia. Alright, I'm going to replace the y in the first equation, so negative 1x plus 2, and instead of 2y, it's going to be 2 times negative 2 equals negative 7. That becomes negative 4 when I distribute. Negative 1x minus 4 equals negative 7. Add 4 to both sides. Negative 7 and 4 make negative 3. Divide, because I remembered to put that 1 in front of the x. Divide both sides by negative 1. Negative divided by negative is a positive. Oops, my 3's. Ay, Dios mío. So the point of intersection is 3, negative 2. And on the last one, again, I had a decimal answer or a fractional answer. I'm going to just use the decimal. You could use a fraction. Really doesn't matter. Both are doable. So 2x plus 4y, y will be replaced with 1.5, will equal 7. So 1.5 times 4 is 6. Subtract 6 from both sides. You'll end up with 2x equals 1. And again, of course, why wouldn't it happen? At least once. Divide both sides by 2 and we end up with a fraction. Well, x equals 1/2. Again, when you put your point of intersection together, x goes before y, so 1/2 comma 3/2. Or if you really prefer the decimals, you can put it point of intersection or your POI at 0.5 comma 1.5. It's up to you. Your prerogative. Just like Bobby Brown said. It's my prerogative. Alright, 16 through 18. Sometimes you need to multiply both equations in order to eliminate one variable. Again, I'm looking for signs that are different to kind of make it most efficient. I don't want to necessarily multiply by a negative if I don't have to. So I notice that y's, the 5y and the 2y, one has a positive, one has a negative. So I'm just going to flip-flop the numbers, multiplying the top equation by 2, multiplying the bottom equation by 5, and it becomes 4x plus 10y equals 90, and 15x minus 10y equals 100. When I combine the equations, I get 19x equals 190, divide both sides by 19, and x equals 10. That went pretty smoothly. In the next equation, notice I have positive and negative signs for the x's. I also have positive and negative signs for the y's. So I can choose to eliminate the x's or the y's. I'm going to stick with the x's just because 3 and 2 are smaller than 3 and 4. So I'm going to flip-flop the numbers and multiply the top by 3, the bottom by 2. So my first equation becomes 6x plus 9y equals 90, and the bottom equation becomes negative 6x minus 8y equals negative 82. 6x and negative 6x cancel out, so the x is eliminated. 9y and negative 8y make 1y, or just y by itself. 90 plus negative 82 makes 8, so y equals 8. Last equation, number 18, has decimals. So you know what? I'm just going to get rid of the decimals. How can I do that, you say? Well, notice I moved the decimal to the right one place. Well, what would I have to multiply to get that? Multiply by 10. If you want to move it 2 places, you multiply by 100. You want to move it 3 places, 1,000. Get the picture? So I multiplied the top equation, bottom equation, both sides of the equation by 10. So the second equation becomes 5x plus 3y equals 8. Still can't eliminate anything because 2 and 5 are not opposites, nor are 7 and 3. So I've got to decide before I make my next move, do I want to eliminate the x or do I want to eliminate the y? So I've got to make a choice and pick. Again, I'm considering the smaller numbers. 2 and 5 are smaller than 3 and 7. So I'm going to multiply the top by a positive 5, but I need to make sure I multiply the bottom equation by a negative 2 so that the x will cancel out. Top equation becomes 10x plus 35y equals 45. Bottom equation becomes negative 10x minus 6y equals negative 16. Well, the x's are eliminated, and 35y plus negative 6y is 29y. I wish I were 29 again. That'd be nice. 45 and negative 16 are also 29. When I divide both sides by 29, I get y equals 1. Now I've got the first variable in each of these equations. I have to go back to one of the original equations and substitute. So I'm going to set them up and you can solve them. I substitute 10 in for x, so I'm using the top equation. So 2 times 10 plus 5y will equal 45. Don't forget your order of operations. You're working on them backwards. So you'll have to distribute the 2. On the second equation, I'm going to use I'm going to use y equals 8 and rewrite the top equation 2x plus 3, and instead of y, replace it with 8 equals 30. Again, follow the order of operations backwards to solve for the x. So 3 will get distributed to 8. Last equation, I'm going to make sure I use 1 for y, and I'm going to go with the bottom equation, so 5x plus 3, and instead of y, I replace it with 1 equals 8.